Good evening, students. Welcome back to chemistry class. Today, let us continue the lesson Carbon and its compounds. In the previous class, we have learned what are saturated and unsaturated carbon compounds, what are hydrocarbons. In hydrocarbon, we have learned different groups of hydrocarbons like alkanes, alkenes, alkynes, cycloalkanes, and in aromatic hydrocarbon we learned one structure, that is benzene. Then we learn how to name the hydrocarbons, that is a nomenclature of hydrocarbons, and how to draw the structure if the name is given. Then we learn the isomerism, what is meant by isomerism and what are isomers and their examples. Today we are going to learn what is meant by functional group and the nomenclature of carbon compounds. Previous class we have learned the nomenclature of only hydrocarbons. Today we are going to learn the nomenclature of a few more carbon compounds other than hydrocarbons. So before learning what are functional groups, let us see what is meant by a heteroatom. So in the previous class we have learnt about the hydrocarbons. What are the hydrocarbons? The carbon compounds that contain only carbon and hydrogen. So this carbon can be linked to some other atoms, elements other than hydrogen. These elements are called heteroatoms. So carbon combines with not only hydrogen but also with other elements such as halogens, oxygen, nitrogen and sulfur. What are these halogens? You have learnt in the previous lesson, periodic classification of elements. You have learned halogens are chlorine, bromine, iodine. These are halogens. So other than not only with the hydrogen but also with other elements like halogen, oxygen, nitrogen and sulfur, also carbon can combine. So in a hydrocarbon chain, one or more hydrogens can be replaced by these elements such that the valency of carbon remains satisfied. So, in hydrocarbon only carbon and hydrogen are present, and we have learned about alkanes, alkenes, etc. So, in this hydrocarbon, instead of one hydrogen, another element can be occupied. That means one element can be replaced by, hydrogen can be replaced by other elements like halogen, oxygen, nitrogen or sulfur. So these elements which occupies the space of the hydrogen in the hydrocarbons, that is, they are called the heteroatoms. In such compounds, the element replacing hydrogen is referred to as heteroatoms. So let us see the examples, then you will understand more. Okay. So next we will learn what is meant by functional group. So already we have seen the heteroatom can be replaced in hydrogens. Heteroatom replaces hydrogen in hydrocarbons. These heteroatoms or the group containing heteroatoms, sometimes a group decide the behavior of an organic compound, and sometimes the heteroatom itself decide the behavior of an organic compound. So these heteroatoms or the group containing of heteroatoms in an organic compound that determines the chemical behavior of the compound is called a functional group. So with the example, if we discuss, you will understand it better. What is functional group and what are these heteroatoms? So the heteroatoms or the group containing heteroatoms in an organic compound that determines the chemical behavior of the compound is called functional group. Let us see. So here in this lesson you are going to learn about 5 different classes of organic compounds. They are haloalkanes, alcohols, aldehydes, ketones and carboxylic acid. So in haloalkane, in the alkane, one or more hydrogen is replaced by either chlorine or bromine. If it is chlorine, that is called chloroalkane. If it is bromine, that is called bromoalkane. So here the functional group can be Cl or Br, chlorine or bromine. So that class of organic compounds which have a functional group chlorine or bromine, they are called chloroalkanes or bromoalkanes. So in this compound, this chlorine or bromine decides the chemical behavior of this compound. So all the reaction is based on this chlorine and bromine. Next class of organic compound, it is alcohol. So in alcohol, the functional group is OH. So which is a heteroatom here? Heteroatom is other than this carbon and hydrogen. Which atom? So here the heteroatom is oxygen. And in chlorine and bromine, haloalkanes, which are the heteroatoms? Halogen. That means chlorine or bromine. So in one class of organic compounds called alcohol, the functional group is OH. So here in alkane, that means the hydrocarbon alkane, one hydrogen atom is replaced by the OH group. Such class of organic compounds are called alcohols. So the chemical behavior or chemical property of this alcohol depends upon the OH group. It does not depend upon the carbon or hydrogen. So this functional group decide the property of an organic compound. Next, another class of organic compound, that is aldehyde. Let us see what is the functional group of aldehyde. It is the CHO group. This together will read it as CHO. Actually the CHO group, C carbon is bonded with a single bond with hydrogen atom and a double bond with oxygen atom. The same CHO group we can draw in different ways. You can draw here the H and here double bond O, or here double bond O, here H. Anyway, you have to remember carbon is bonded with hydrogen with a single bond and with oxygen with a double bond. That is a CHO group or aldehyde group. The organic compound which have this CHO functional group, that is called an aldehyde. Next class of organic compound is ketones. In all the ketones, there will be a functional group CO. CO group is C has double bond with oxygen and the C is attached to here one group of alkanes and here one group of here it is attached to carbon. When we see the example, you will understand it more. Next class of organic compound, it is carboxylic acid. In all the carboxylic acids, the functional group present is COOH. COOH, the actual structure is C double bond O single bond OH. So we have seen now different functional groups. Which are they? Chlorine or bromine. The class of organic compound which has the functional group chlorine or bromine, they are called chloroalkanes or bromoalkanes. In general, we can say haloalkanes because chlorine and bromine are halogens. Now, the organic compounds or carbon compounds which has a functional group OH, they are called alcohols. The organic compound which have the functional group CHO, they are called the aldehydes. The organic compound which have the functional group CO, they are called the ketones. And the organic compound in which a functional group COOH is present, they are called the carboxylic acids. So you should be thorough with this table. Once again, alcohol, the class of organic compound alcohol, which is a functional group OH group. The class of organic compounds called haloalkane, chloroalkane or bromoalkane, which is a functional group chlorine or bromine. Aldehyde, class of organic compound called aldehyde, which is a functional group CHO. Actual structure C double bond H, single bond H, double bond O. The organic compound called ketones, which is a functional group CO, C double bond O. And the carboxylic acid, the group of class of organic compounds called carboxylic acid, the functional group is COOH. Next, we are going to learn the nomenclature of these carbon compounds or organic compounds. So, how to name them? These 5 different classes we have learned. These 5 classes of organic compounds, how to name them? So let us see how to name these 5 classes of organic compounds. So some organic compounds, to name them, we are giving the prefix. Prefix means what? The before the name what we are adding. The corresponding alkane name. Prefix we are adding chloro or bromo if it is a haloalkane. Other class of organic compounds like alcohol, aldehyde, ketone and carboxylic acid, we are adding the suffix. After the alkane name, we are adding suffix. If it is an alcohol, we will give the suffix OL. Aldehyde, AL. Ketone, ONE. And carboxylic acid, OIC acid. So, if it is an alcohol, we are giving the suffix OL. Aldehyde, AL. Ketone, ONE. And carboxylic acid, we are giving the name OIC acid. Let us see the examples. So, how to name the carbon compounds? First example, let us see. One structure of an organic compound is given. You have to name it. So, the first step is to count the number of carbon atoms here. Carbon chain. How many carbon atoms are present in the carbon chain? So, here you can see 3 carbon atoms. Then give the corresponding alkane. You know already the alkane which contain 3 carbon atom is propane. So let us see here. Naming of carbon compounds can be done by the following method. First step, identify the number of carbon atoms in the compound. We have identified, here it is 3 carbon atoms. So what is a alkane which has 3 carbon atoms? A compound having 3 carbon atoms, that is a propane. Next we have to see which functional group is present in this. So here you can see the functional group is OH. This term sometimes we'll write together O together H will write. Sometimes it will be showing the between O and H also one covalent bond is present. Sometimes the covalent bond also will be shown here. Otherwise simply OH. So here which functional group is present here? OH. So already you have seen OH functional group is present means that is an alcohol. So how to name an alcohol? We have seen the prefix or suffix also. What is the suffix we have to give? Al. So corresponding alkane, this end E is replaced by Al as it is an alcohol. Already we have seen in this table, alcohol means we have to give the suffix OL, aldehyde Al, ketone ONE, carboxylic acid OIC acid. Remember these points. So let us see here. We have identified the corresponding alkane here, propane. Next step, in case of functional group is present, it is indicated in the name of the compound with either a prefix or a suffix. So we have seen chloro or bromo alkane, we are using the prefix. Before the name we are adding that chloro or bromo. Other class of organic compounds like alcohol, aldehydes, ketones and carboxylic acid, we are giving the suffix. After the name, we are giving the suffix. Now, if the name of the functional group is to be given as a suffix, the name of the carbon chain is modified by deleting the final E and adding the appropriate suffix. That means the corresponding alkene name E is replaced by, here as it is an alcohol, what suffix we have to give? OL. So the name of this compound is propanol. Once again, let us see, an organic compound is given. We have to name it. What are the steps? First, we have to count the number of carbon atoms. Next step, give the corresponding alkane name. Next step it is find out the functional group. Identify the functional group. If the functional group alcohol OH, CHO, COOH or CO, we have to give the suffix. E, the final E is replaced by the corresponding suffix. If it is chlorine or bromine, we have to give the prefix. Before the name, we have to give chloro or bromo. So here, as it is alcohol group or OH group, the E is replaced by OL. The name of this compound is propanol. Next example. Here, this is the organic compound given. We have to name it. So what is the first step? Identify the number of carbon atoms. How many carbon atoms are present in this compound? 1, 2, 3, 4, 5. Next, what we have to do? We have to give the corresponding alkane name, which is the alkane having 5 carbon atoms, that is pentane. Now, next step is the E should be replaced by the uh, identify the functional group in this. The functional group is CHO group, that is the aldehyde group. What is the suffix given to an aldehyde? It is Al. So this E is replaced by Al. So what will be its name? Pentanal. Instead of E, we have to give Al. So name of this compound is pentanal. Next example. The carbon compound given. First step is to identify the number of carbon atoms. So here there are 1, 2, 3, 4 carbon atoms present. So which is the corresponding alkane? Alkane having 4 carbon atoms, that is butane. Now next we have to identify which is the functional group present here. COOH. What is the functional group? Carboxylic acid. So how to name a carboxylic acid? We have to give the suffix. What suffix should be given? Oic acid. We have seen already. So butane, E should be replaced by oic acid. So the name is butanoic acid. The name of this compound is butanoic acid. Next example. So here, first step to count the number of carbon atoms. How many carbon atoms are present in this? 3. So the name of the corresponding alkane is propane, which is having 3 carbon atom. Next, which is a functional group present in this compound? CO, C double bond O. What is that functional group? Ketone. What suffix should be given for ketone? ONE. So this E should be replaced by ONE. So name of this compound is propanone. So remember here, CO group is both common for aldehyde group and ketone group. Ketone group will be present in between 2 carbon atoms. CHO, if it is CHO group, previously we have seen that aldehyde, CHO group will be at the end. C attached to H and attached to one double bond O. Remember that. So don't confuse while giving the name, don't confuse with the CO group. Next example. This first step to name this compound. First step is to count the number of carbon atoms. 2 carbon atoms. The corresponding alkane is ethane. Next, the functional group here is chlorine. So chlorine or bromine is a functional group. We have to give the prefix. Before the name we have to add the prefix. So what is the prefix should be given here? What prefix should be given here? Chloro. So the name of this compound is chloroethane. Without gap, you can write this as one word. So the E should be small letter. Next example. So first step is to count the number of carbon atoms. There are 4 carbon atoms. So the corresponding alkane is butane. Next we have to see which is the functional group. The functional group present is Br or bromine. So the corresponding alkane butane. Functional group is bromo. So we have to give the prefix bromo. The name of this compound is bromobutane. Next we'll see how to draw the structure of the compounds if the name is given. So here ethanoic acid. These questions are in your textbook page number 12. Question number 4 it is. Ethanoic acid. So to draw the structure, first you have to see from the name. It is derived from which alkane? And from the name of the alkane, you will get how many carbon atoms are present here. So ethanoic acid. Ethane is replaced by oic acid. So as oic acid is, the name is oic acid, you can understand a carboxylic acid group is present here. The functional group present is carboxylic acid or COOH. It is a carboxylic acid. And from this name ethane, ethanoic acid, it is a derivative of ethane. We can understand 2 carbon atoms are present. So first we'll draw the carbon chain with 2 carbon atoms. Next, as it is oic acid, one should be a carboxylic acid. Including the carboxylic acid group, there are 2 carbon atoms. So one carbon you can make it as a carboxylic acid group C double bond O single bond OH. Other carbon to satisfy the valencies, you can draw the hydrogens. Here 3 hydrogens you can draw. So here drawn 3 hydrogen with a single bond. Here this you make it as a functional group C double. So here for this carbon, remaining 3 valencies are satisfied with the hydrogen. This carbon, make it as the functional group as it is a carboxylic acid group. Carboxylic acid, we have to give the functional group C double bond O, single bond OH. So including this, there are 2 carbon atoms. Remember that. You are not attaching functional group another COH group to this, including this functional group also included in these 2 carbon atoms. So 1 carbon you make it as the functional group here. Next example, bromopentane. So this is which class of organic compound? Bromoalkane. So pentane is having 5 carbon atoms. So draw with a carbon chain with 5 carbon atoms. Next what we have to do? Bromopentane means the functional group is bromine. So to this carbon, you have to attach one bromine. Remaining bonds should be satisfied with the hydrogen. There should be 4 bonds already you have seen. The previous class, there should be the valency of carbon is 4. 4 bonds should be present for the carbon. Remaining you can write with the hydrogen. So here this bromopentane means there are 5 we are drawing first the carbon chain containing 5 carbon atoms. So in bromo group there is no carbon in the functional group. So in this 5 carbon you have to attach one bromo, Br group. In this example you see functional group itself one carbon is present. So including that only we have got the name ethanoic acid. So one carbon you have to make it as a functional group. Here in bromopentane, in the functional group, there is no carbon, bromopentane or chloropentane. So, to this carbon, you have to attach one bromine. Next example, butanone. Butanone means how many carbons will be present? There should be 4 carbon atoms. For the name butane, denote 4 carbon atoms. So, draw one carbon chain having 4 carbon atoms. Next, we have to see the suffix what is given here, ONE. ONE suffix is given to which type of organic compound? Ketone group. So ketone group, what is a functional group? C double bond O. So here already we have seen CO group will be present in between 2 carbon atoms. So don't give the CO group to one end carbon. End carbon if you are giving one CO, to satisfy the valency here we have to give hydrogen, that is an aldehyde group, CHO group. So end carbon don't make it as CO. You can make in between this carbon or this carbon, you can make it as CO group. So remaining valencies can be satisfied with the hydrogen. So this is the butanone. You have made this as the functional group CO. Remaining valencies are satisfied with the hydrogen. For this carbon, already 4 bonds are present, so no hydrogen here. Next example, hexanal. Hexanal. Hexane means how many carbon atoms? 6. So draw the carbon chain containing 6 carbon atoms. So as the suffix is Al, which class of organic compound it is? Alcohol. Alcohol only we are giving the suffix Al. Alcohol, what is the functional group? OH. So to this attach one OH group here. Remaining valencies should be satisfied with the hydrogen. So this is the structure of, hexanal. Al means that is aldehyde, not alcohol. Hexanal. Hexanal means we have to give the aldehyde functional group. Aldehyde functional group is CHO. As the aldehyde functional group, one carbon is present. One carbon you can make it as the functional group. So C double bond O, single bond H. Hexanal. If it is OL only, that is alcohol. Al means aldehyde. Don't confuse. Next, butanol. Butanol means 4 carbon atoms. So we have drawn the 4 carbon chain containing 4 carbon atoms. As OL is the suffix, that is a alcohol functional group having the alcohol. The class of organic compound is alcohol, which has the functional group OH. So this carbon can be attached to OH group. Remaining valencies you can satisfy with the hydrogen. So this is the structure of butanol. So once again, how to draw the structures? If name is given, first you have to, from the name you will get how many carbon atoms are present, draw the carbon chain. Next you have to see the suffix or prefix. Accordingly, you will get which functional group is present in that. If it is CHO, CO or COOH, one carbon itself you can make it as the functional group. If it is Cl, Br or OH, one carbon can be attached to this functional group. Remaining valencies can be satisfied with the hydrogen. Next, how can give the name of the compound? This question also there in the textbook page number 12, question number 5. So how to name this this organic compound? So first we have to see how many carbons are present. There are 2 carbon atoms present. So the corresponding alkane name is ethane, and which is a functional group present here? Bromine. So how to give the name for the bromoalkanes? Bromo prefix should be given to the alkane. So bromoethane. Same compound, both are same. Here CH3 together it is given CH3. C is attached to hydrogen atom, it is given CH2 and Br. Next compound it is. The compound we have to give the name. So first step what it is to give the name? We have to identify how many carbon atoms. How many carbon atoms are present here? Only one carbon. Which is alkane having one carbon? Methane. Next we have to identify the functional group present here. So which is the functional group present here? The functional group is CHO group. CHO means aldehyde. Aldehydes, how to give the name? End E of the alkane should be replaced by Al. So the name of this compound is methanol. Next compound it is. So how to name it? This does not contain any functional group, but it has a triple bond. Already we have seen the hydrocarbon containing triple bond, how to give the name. We have to count the number of the carbon atoms 1, 2, 3, 4, 5, 6. So the root word is hex and is containing a triple bond. So name should be given, suffix should be added YNE. So hexine. So name of this compound is hexine. So let us see this table once again to recapitulate. So we have learned today 5 classes of organic compounds: haloalkanes, alcohol, aldehyde, ketone and carboxylic acids. Alkene and alkane already we have learned in the previous classes. So haloalkane, the class of organic compound, the functional group is Cl. To name this organic compound which contain chlorine or bromine, we have to give the prefix chloro or bromo before the alkane name. So here you can see 3 carbon atom having 3 carbon atom, which is that alkane? Propane. So prefix is given chloro. So the name of this compound is chloropropane. This compound bromopropane. Now for alcohol, which is a functional group? OH. How to give the name? We have to give the suffix OL. Identify the alkane, corresponding alkane. The E of the alkane should be replaced by OL. So here the corresponding alkane is propane. E is replaced by OL. So name of this compound is propanol. Next class of organic compound, aldehyde. Aldehyde functional group is CHO. And to name it, we have to give the suffix Al. So here you can see 3 carbon atoms are present. The corresponding alkane is propane. So as it is an aldehyde, the CHO is a functional group present in this compound. It is an aldehyde. As it is an aldehyde, propane E should be replaced by Al. So name of this compound is propanol. Next, the class of organic compound ketone. The functional group is C double bond O. This CO group will be in between 2 carbon atoms always. So the name should be given ONE as suffix. So here you can see 3 carbon atom, that is propane. The corresponding alkane is propane. So to give the name, the E should be replaced by ONE as it is a ketone. Next, carboxylic acid, another class of organic compound. The functional group is C double bond O single bond OH or COOH. If it is present, that is a carboxylic acid. To name it, the corresponding alkane E should be replaced by the suffix oic acid. So the name of this compound is propanoic acid. And how to give the name for alkenes and alkynes we have discussed already in the previous class. We have to identify the name of number of carbon atom, the root word you have to give, as it is 4 carbon atom. Here, as the number of carbon atoms are 3, the root word is prop. As a double bond is present in this hydrocarbon, we have to give the name ENE to the root word. So, name is propene. Similarly, for alkyne, you have to identify whether this is a hydrocarbon, you know, because only carbon and hydrogens are present. If it is a hydrocarbon, you have to see whether all the carbon-carbon bonds are single or any double bond is present or triple bond is present. So, all the carbon-carbon bonds are single means to the root word you have to give the name ANE suffix. If it is double bond is present, you have to give the ENE suffix to the root word. If any triple bond is present, you have to give the name YNE to the root word. This already we have discussed in the previous class. So today we have discussed what is a heteroatom. So we have seen 5 classes of organic compounds. In that the heteroatom present in chloro or bromoalkane, it is chlorine or bromine. All other class of organic compound, the heteroatom present is oxygen. And we have learned what is a functional group. What is a functional group? The heteroatom or the group of heteroatom that determines the chemical behavior of the compound. That is called the functional group. Then the 5 types of functional group we have learned, and which contain this functional group, the 5 different classes of organic compounds also we have learned. So the classes of organic compounds are haloalkane. It can be chloroalkane or bromoalkane. In this compound, the functional group is Cl or Br. Next, we have learned other class of organic compound, alcohol. In that, the functional group is OH. Aldehyde, the functional group is CHO. C single bond O, double bond single bond H and double bond O. And next class of organic compound we have learned ketone. The functional group is C double bond O. Next it is carboxylic acid. The functional group is COOH. C double bond O, single bond OH. Then we learn the nomenclature of carbon compounds, how to name them. Hope it is clear for you today's class. Thank you, children.